let's get started. So some announcements first. Just to remind you, if you haven't taken the pre-test yet, today's the last chance. You need to be in the door before 6:30 tonight. You need a sun card. Don't bring a calculator. You don't have to study, but do your best. You can earn some extra credit on exam 1. Okay, it should take average 45 minutes. Those of you taking it, about 40 minutes, 45 minutes? Yeah, that's about right. Okay. So allow yourself that much time. Also, on the blackboard over here to the left, inevitably, you're going to not have seen or asked a question before, and you're going to want to know when is office hours. Okay, they're on the syllabus, but they're also right here on Blackboard. If you just click on this menu link over here on the left, all the info is right there. So if you ever want to come talk to me and get help, which I encourage you to do, office hours. And then there's also opening, I'm not sure if it's opening this Thursday or for sure next Tuesday is the lab. The lab is in, or the tutor help room. That's in ECA 216. And that's open Monday through Thursday, 9 to 6, Fridays, 9 to noon. Okay? And those are that tutor room is specifically for our curriculum, Pathways Pre-Calculus. So the tutors are at least familiar with it. Some have more training than others. So if you don't have a good experience, go a different time, find someone that you like. There are tutors that can definitely help you there, and they're very familiar with this curriculum. Let's see, what's today, Wednesday? For sure Tuesday. It may be open tomorrow. If you're interested in going either tomorrow or Friday, email me and I'll let you know if it's opening yet tomorrow. But for sure, we're in full swing on Tuesday on that. Okay, any kind of general questions, pre-test? Oh, let me show you. So written homework. Everyone should have gotten an email from me. You should have gotten an email from me. I sent an email on Monday just to clarify what was going on. I said that what I had you do for Monday, the worksheets, I'm going to check that today in class. And then for Wednesday, this is the first kind of official homework assignment. Starting on page 55 in Module 2, there's this list of problems. When you're doing homework, there's no room to put your answers, and you're turning this in. So you need separate sheets of lined paper. Half the points are for neatness, organization, presentation, and most importantly, completeness. So when I say completeness, there's lots of these questions in here that will say, explain your reasoning. Okay? That's code for your writing sentences. Okay? This is very uncomfortable for some students because they've not been asked to do this before. But we're kind of trying to force you towards a kind of higher level of understanding. And in order to write out and explain something in complete sentences, that requires a higher amount of understanding, and that's what we're going for. So by completeness, anytime it asks you to explain your reasoning, that means you're writing sentences. Okay? And that's very common in these questions. All right, so that completeness is worth half. The other half is accuracy somewhere in the assignment. You don't know where, so it's kind of be randomly chosen for what's going to be actually graded for your accuracy. Okay, so here's the list. This is due a week from today. This is our first.
5 from A through I, just A through I, one of those 5?
Yep, any 5 from A through I of your choice. Yeah, you'll see it, number 9. Other questions about this homework? If you did not get an email from me, then you have to adjust your settings or your forwarding. Whatever email you're using, you got to get your ASU account forwarding to the one that you use. Because I do send out emails. Like, sometimes I run out of time at the end and there's an announcement I'll forget. I'll shoot you guys an email. So make sure, if you did not get that email from me Monday, that you figure out what's going on with your ASU account. I'm sending emails right through Blackboard. Yes, sir?
What segment of Blackboard is the recorded lecture?
Oh, I haven't put that up yet. There will be, so I'll probably do that tomorrow. Tomorrow I'm going to add a new menu item here. It'll be class videos. There'll be a new menu item here, class videos. I actually messed up. I didn't get Mondays on tape, but I got Fridays, and we'll get today's. And then every day from there. So that will be, I'll get that up tomorrow, this new link called Class Videos. Any other questions? Okay, so we were in worksheet 2, and we were working on problem 2, which was the pain medication problem. And remember that we had assigned, we'd assigned these quantities, right? Did we call it M and W? Something like that? The volume of medication in milliliters, volume of water in milliliters. And what they said was the correct relative amounts of these to get the right dosage was if you had 3 milliliters of pain medication, how much water would that take? 2. It was 3 to 2, right? Okay, so we were talking about some different ways of thinking about proportional quantities. And we were kind of a little rushed at the end, so we want to take some time to really flesh this out. So the first one I mentioned was scaling factor. So for instance, if I had 7 times as much I want to scale up the amount of pain medication by 7. How much would that give me? 21. Okay? And so now I'm going to put in 21 milliliters of pain medication. So how much water do I need? And where does the 14 come from? If I'm going to multiply the 3 by 7, uh-oh, is it freezing up? What's going on? Then I've got to multiply the 2 by 7. And so how much is it? Okay? This is scaling factor reasoning. You take one of the quantities and you scale it, either magnify it or you shrink it. If you've got a proportional relationship, you must do the same with the other. Okay? So, if I want, say I've got 3/10 of a milliliter of pain medication. And we're going to use scalar factor reasoning. What was my scaling factor? 1? 0.1 or 1/10, right? I took 1/10 of the amount. So how much, what do I have to do to 2 milliliters to get the corresponding amount? Multiply it by 1/10. And that will be 0.2. Okay, that is scaling factor. If you have proportional quantities, this will always work. Scale up 1, the other amount gets scaled up to the same amount. Okay? That's called scaling factor reasoning. Okay, and then we also mentioned another one, which was, so these, the ratio of medication to water is 3/2 or 3 to 2. So that ratio must be maintained. We call this common ratio. That ratio must be maintained. So if I have all right, so let's just start with that. So if it has to be in a 3 to 2 ratio, then we're asking how much water is going to maintain that 3 to 2 ratio? 200 milliliters. Okay, another one. Trying to think of an easy one. How about 60? So we need a 3 to 2 ratio. What amount of water, 60 milliliters of medication is going to maintain a 3:2. 40. This is common ratio reasoning. So if the numbers were hard, like, so I gave you two easy examples. So if you had something like, all right, now I open up some pouches and I find that it's 67.8. So what we're saying is, what amount is going to maintain this 3:2 ratio? So as long as you have that kind of thought process to set this up, then now cross multiplying is okay. Okay, so the thought process is the important thing. When you have numbers that are nice, now we can use cross multiplication to solve for that question. Okay, but the idea is the important thing. We're maintaining the same ratio. Okay, so that's common ratio. There's one more aspect of looking at proportionality, and that is if we look at Part E, Worksheet 2, Part E. It says, what formula might the nurse use when mixing pain medication for children under 6 years of age if she wants to determine the volume of water to add to any volume of pain medication? Okay, so the idea is we've got the amount of pain medication that we want, or that we're going to use. So is there a formula that will crank out the amount of water that we need? So let's go back to our table up here. I'm going to erase this stuff. Okay, so what we're saying now is if we have the amount of medication, what formula then will generate the volume of water? So let's just do a couple more here. What if I had 30? Okay, so that's scaling up 3 by 10. So we got to scale up 2 by 10. All right, so maybe that's enough. So now, oh, we didn't get this one. Where's that? So what we're asking is, what formula could we plug 3 into that would crank out 2 for us? We could plug 21 into it, it would crank out 14. We could plug 30 in, it would crank out 20. So that's what they're asking in Part E. So take just a moment, maybe work with the person next to you. What you're saying is you want a formula that you can plug the number in the left in and it will crank out the number on the right. Some of you probably already have it, so just take 30 seconds to talk about it. Go. So this is what we're asking. So we're saying we've got M. What do we do to M mathematically to get W? So what do we need to do to M mathematically to get W? If 3 would give us 2,
Multiply it by 10.
21 would give 14. You want to multiply what by 10? M? How about this? So if we take the amount of medication and multiply it by 10, it gives us the amount of water. So that would mean that if we took 3 and multiplied 3 by 10, we should get 2. Yeah? All right, you said M times, oops. What'd you say? 2/3. Does it work? 3 times 2/3 is 2. 21 times 2/3. The volume of water is always what? 2/3 of the amount of medication. This is different than what we taught. This is not scaling factor anymore. So this is always times what? 2/3. Do you see that that's different than scaling factor? Scaling factor is when you have one quantity and you change that quantity, scale it up or you shrink it. Then you must do the same to the other. This is saying if I've got the amount of medication, what do I multiply by to get the corresponding amount of water? It's two different things, you see? This is called constant multiple reasoning. So constant multiple reasoning is, what is that one constant? So 2/3 is a constant here, right? It doesn't change. It's always the number, no matter what the amount of pain medication is, we always multiply it by that 2/3, and it gives us the amount of water. Okay, so in the worksheet, it was talking about writing one quantity in terms of another. Writing one quantity in terms of another. So this right here is either W equals M times 2/3. That's either writing W in terms of M, or it's writing M in terms of W. We got to have that language straight, so we'll use that language all semester. Which one is this? Is this W in terms of M or M in terms of W? You're so smart. W in terms of M. That should make sense. We're saying, what is W? W equals some expression in terms of M. Okay, so that's going to be important language that we'll have. Okay, so what you're going to do is I'm going to give you a bunch of problems to do. You're practicing, no matter what the question asks, you're practicing these three types, or maybe in any given situation, at least two of the types of reasoning. So we got the scaling factor, we got the common ratio, and we got the constant multiple. Okay? All three are different ways of thinking about proportionality. And as I assign these, you're going to be practicing that. So don't just be like, oh, I've done these in the past, I'll just do it this way, the way I used to do it. You want to practice talking about and thinking through those different ways of reasoning about it. So you're going to first do number 4. Okay? So first do number 4, A and B. So you're going to be, and then go back and do number 3. Remember, the goal always in answering these questions is practicing what we just learned, the 3 types of reasoning about proportionality. Okay? And that will use conversations to help you with that. As you're doing that, I'm going to call you down in groups to do the check for worksheet number 1. Okay? So there's plenty of work that I've given you. Number 4 and number 3. Stay on task. There's 2 4s?
2 3s. There's one with A, B, and C.
Okay, so I want the 4 with the tables, and then the 3 back on page 23. So you're going to go start on page 24, do number 4, then page 23, number 3. And when I call your group, you've got to bring your workbook with you, obviously. That's what I'm checking. So I need last names. Abad through Burke. Abad through Burke. And just come on, just make a line right up the stairs here. So bring your notebook, Abad through Burke. The rest of you, staying on task, number 4 and then number 3. Go. Yeah, it doesn't have to be in that order, okay? Just those people doesn't have to be in that order. Great, what's your last name? Okay, gotcha. No problem. So it would be on 2B. And then 5B. Great. What's your last name? Gotcha. Look at that one again. It's greater than. Think about that one again. Yeah. What's your last name? Alden, Jacob? Okay. It's not changing? You still also rethink that one right there. What's your last name? Bentley? Okay, I got you. Rethink that right there. Right, and then the volume. This is the volume of the water in the bottle, not the volume of the water. Okay, what's last name? Gotcha. CJ. Okay. Yeah, so the assignment, that was, the assignment for Monday was to work through the whole sheet.
Yeah, I did not. I attempted it.
Okay, what's your last name? Okay, so if you want to take the initiative to find me again, I can change your grade, but right now, I can't give you credit. Was that everyone? Abad through Burke? Last names? A, B through Burke? Lots of people didn't come up. B-U-R-K. So if your last name is between A, V, and B-U, you're coming up here. Between Abad and Burke. It's asking for the variable. So that's also you better think this. We want 8 particular quantities, 6 greater than, like that's the single quantity. Think through that again. It's not saying greater than or less than. It's saying if you had this quantity and you wanted 6 greater than that quantity, how would you express it? What's your last name? Oh, gotcha. Okay. What's your last name? Hala? Oh, Alia, sorry. I gotcha. Okay. What's your last name? Balsai? Yeah. So if you want to take the initiative to show me after you've done it, I'll change the grade if you want. Right now you don't have a grade for that. Yeah, one-time deal. What's your last name? Starts with E? I haven't called you up yet. This is A through A and B. But so what is it? This one? Yeah. Ahmad? Yeah, one-time deal though. So from here on out, if you don't have it done, when it's due. Okay. Yeah. Okay. Oh no, it's going to be too hard. So if you want to do the right one and then come back to me, what's your last name? Okay, you got a 0 right now, but if you can get back to me later. Okay, Burroughs through Freeman. Burroughs through Freeman. Yes, sir.
For B, when it's asking the difference, what is the writing tables that represent proportional relationship between two quantities? What is the relative size of the output values compared to the corresponding input values?
So what's the relative size of the volume of water compared to the volume of medication? What's the relative size?
Okay.
How big is volume of water relative to medication?
Okay, got it.
So, but you have different contexts there. Nice. Last name. Good job. Thank you. Gotcha. Page 18. Never ready for page 18. Okay, gotta rethink that. Everyone understands that. This is really important. You don't understand what these things are. So we'll do that again. What's your last name? Okay, gotcha. Okay, so 2B and 5. Rethink there's something wrong in there, rethink it, and then what about 5B? That's good. Last name? Think through that table. There's something wrong in there. There's something wrong in this table. Think it through. That's good. What's your last name? Gotcha. Okay, you got 2 things wrong in that table. What's your last name? File. Sydney?
Yep.
Okay. Who's next? This actually. That looks good. That looks good.
I did those backwards. I think.
No, it's right except for the way that you took the percent of y. Looks like you're multiplying 825 times y. That's not what will give you the percent. Do that again. What's your last name?
Fraser.
Okay, I gotcha. Table. It's good. It's good. And then 5B. Looks good. Last name. Oh, jumped the gun there. You're all right. Connor? Okay. You're good. Next. Okay, will that give you percent of y? You multiply by 82.5? What's your last name? Emily?
Yep.
I got you. Fulton through HE. FU through HE. Fulton through.
Right.
That's good. Not quite. Think through that again. That won't give you the percent of y. Go ahead and make a line this way, and have it ready for page 18. No. What's your last name? Okay, just rethink how you would take 82.5% of y. Okay, one of those is not right. Rethink it. Okay, that looks good. What's your last name? Say it again. Sabrina? Okay. One of those is not right. Rethink through that. Okay, last name? Cole? Gotcha.
I didn't understand this, but you just said
Good. I'm not checking it. So how would you get 82.5% of y without using the percent symbol? What's your last name? Kylie? Okay. Yeah, so we want to kind of tidy up that notation right there. So it's out the percent. Yeah. Okay, looks good. E equals. We need, so we gotta be a lot more precise in the way we do that. What's your last name? So we want an expression that will give us the value. We've got symbols kind of all over the place here. Yeah, think about it. Next. Sorry, don't have time. Okay, what happened there? Yeah, so for these, you're picking which ones of these will go in the boxes.
Well, I understood that, but it's like the same thing. So it's just
So here, this is the attribute. It's going to be one of those. Should fit there. One, the unit for the water in the bottle is going to be one of these.
okay.
That looks good though, so you're going to have to rework that. What's your last name?
Here it's like,
Connor? Okay, I got you. Looks good. Perfect. What's your last name?
Hi. H-E-I-N.
Shelby?
Is there anyone that can talk to the
Absolutely. Next page. Oh, okay, we got to rework this. We missed the boat on this one. So we really got to know what these things mean. And then, yeah, map two. So, if you need help, find me if you need help because we're off track there. What's your last name? What is it? Last name? Barbara? Gonzalez. I got you. One of these is incorrect, so you got to rethink it. And then how can you write this without the percent symbol? What's your last name? Say it again? Garcia. I don't see you on the list. Are you in? Oh, this one. Oh, sorry. I was expecting a dash. Okay, I got you. 18. So we got to rethink these. We got several of these there. So we got to really make sure we know what's being asked for there. You kind of mix. Okay, so make sure you get the help that you need. That looks good though. Okay, what's your last name? Okay, yeah, make sure you get the help on that.
Okay.
Yeah.
What?
What?
Can you help?
Of course. Gotta find me. So all of these are going to be from this list. So these two will be from that list, yeah. It's just a one word describing the attribute. I think so. No, actually not. That doesn't match up with that. Cubic inch and height is not. Volume is not a unit. We got lots of problems here. We got to rework that. That looks good, except for that won't get you the percent of y. Most likely. Yeah. What's your last name? Harris. Okay, gotcha. All right, I'm going to work through table 1 and show you kind of what I was looking for in terms of your approach. Four and 10.4. Five and 12.5. Okay, so you can choose anything you want. You got 3 different ways to reason about proportionality. We got scaling factor, common ratio, constant multiple. Which one do you want to do? Yeah. Constant multiple. So how would we find constant multiple means that there is a value that would get us from 2 to 6.2. What is that constant multiple that would get us from 2 to 6.2? Okay, so if you couldn't see it, if it was kind of difficult numbers, how would you get that value? How would you get, what is the value that multiplied by 2 gives 6.2? 6.2 divided by 2, right? So 2 times 6.2 over 2 would give 6.2. So that we know is 3.1. If this is in a proportional relationship, then what has to also be true?
All the other sets of numbers.
Yeah, so 4 times 3.1 ought to be what? 10.4. And 5 times 3.1 ought to be? Is it true? No. You can stop right there. As soon as 4 times 3.1 isn't 10.4, case closed, right? Case closed. Times 3.1. No. So as soon as you have so what happened? The multiple didn't remain constant. We need a different multiple to get from 4 to 10.4. So we don't have a constant multiple. Therefore, not proportional. Okay, let's do just one more. The next one. Well, I think that's good. And that's the way you're going to approach all these. So once you're done with number 4, you're going to go back to number 3 on 23. You're analyzing those real-world situations the same way, explaining why it is proportional or not. Okay? How many people have gotten to 3b already? All right, you might need some more. So if you finish number 3 all the way through C, then I want you to start on page 20, start on worksheet 3. Only if you finish. Take your time and make sure you understand this. Also, when you go from one problem to the next, practice a different kind of reasoning. So like on the next problem, don't do constant multiple again. Test it for scaling factor. And then the next one, test it for common ratio. So make sure you're going through all 3 kinds. You don't have to do all 3 kinds in every problem, but as you go from problem to problem, switch it up and make sure you understand them.
On the scaling factor, how would you go about it? Is it just kind of plugging in numbers to figure out what multiplied?
So let's just do it for this one. So what's the scaling factor from 2 to 4? It's 2. So we go over here and check. What would this? So we need the same scale here. So we're saying, is 6.2 times 2 equal to 10.4? Is it? No. So that's also showing not proportional. Okay? So mix it up as you go from problem to problem. If you finish all the way through number 3, start on page 27. Number 3. If you get through 3C, then just go to the next worksheet. Okay.
18, right?
What's your last name?
Grant.
Yeah, there you are. Okay, page 18. Okay, one of those is not right.
Okay.
And that isn't right. That won't give you the percent. How will you get the percent? 82% of what? Okay, gotcha. Yeah, rethink it. Jones through Marrero. Jones through Marrero. Page 18. That's good. Okay, so this isn't saying this isn't greater than. This is like a quantity. If we wanted 6 more than that percent. So you have that number, and now you want 6 more than that. 6 more than. How do you get 6 more than a quantity? It's easy, right? No. Keep thinking about it. What's your last name?
L-U-O.
This one?
First, yeah.
Okay. Oh, the first one?
Yeah.
With a B?
Yeah.
Okay, I gotcha. That's page 18. You got page 18 ready. Yep. Good. Last name? Nicholas? Gotcha. All the way over. If one of those isn't right, look it over again, and that will not give you 82.5% of Y. Last name? Next. One of those is not right. Rethink it. That looks good. What's your last name? Jennifer?
Yeah.
Okay, gotcha. Okay, those aren't units. Those are variables, right? Okay, these are your units. So, and then one of these isn't right. So you got to rethink that table. That looks good. What's your last name? Oh, you're fine. You're good. Rethink that table. You got to work it out again. What's next? Last name? Marissa?
Yeah.
Page 18. Okay. That's not a unit. That's an attribute. So that's right. And these are units. See, inch and cubic inches, those are units. So all this is changing or not changing. That looks good. Good. Rethink that table. What's your last name? Sorry. Good. Good. Okay, this isn't saying like greater than or less than. It's saying if you want the quantity that's 8 more than this, how would you write that? 8 more than that. Yeah. What's your last name? Good.
Yeah.
Okay, but then there's also one more thing that's incorrect about that. Besides slow switching, you got something else that's wrong, and then that will not get 82.5% of y. What's your last name? Gotcha. Those look good.
Sorry, I didn't feel like I had enough room.
Okay, we got a couple of things wrong right there in 5D. So rethink that one. What's your last name?
Jump.
Hannah?
Yes.
Okay, I got you. Last name?
Car, K-A-R-O. Terrence.
Parents. Okay. Good? Good? Wow. What's wrong with that? How could you just do it? Do it. Oh, I
Put
see.
in 825 over 1,000.
Yeah, okay, sure. Okay. Next. Last name? Okay. Good. Okay, one of those is incorrect. And that will not teach you 82.5% of y. You think that too. So, okay, gotcha. Last name? With a what?
M-A-R-R.
M-A. Gotcha. Okay, page 18. One of these is not right. So it's this row right here.
Okay.
This row, they're just asking, is it changing or not changing? Changing or not changing? So, okay. What's your last name? Oh, no, gotcha, I gotcha.
I just switched to this class
Okay.
and I went to go over and they are completely out.
Did you go to Corner Bookstore?
Yeah.
College and university?
Everywhere. They
Okay.
have to order it.
Okay.
So I have to go get that checked
What's your
out.
last name?
That's more. Garrett.
Okay, so for now you will have a 0, but if you take initiative, it'll be that worksheet, mod 2, worksheet 1. You do it and take initiative to get back to me.
Is it the worksheet? Is it on Blackboard? So
It's listed on the assignment. Yeah.
Okay, so just once I get the book, I can do it.
Yeah. And then just hunt me down and get your points for it.
And the testing center is right below here?
No, this is PSF. You have to go outside. It's close. It's actually a different wing of this building. So you got to go outside and go to PSA.
Okay.
It's PSA 21.
Okay, cool, thank you.
There's signs.
What's that? Yeah.
Yeah.
You got to get to the right place though.
I saw this and I was like, wow, they really don't want you to lose your way. I found it really easily.
Okay, let's talk about one or two of these. The number 3, the application problems. Is there a request? Was there one that you want to talk about? B? And which was that?
Cable TV company charges.
Cable TV. Okay. Oops. All right, so a great way to analyze this is make a table. Make a table. We got number of months using cable TV, accumulated cost of the cable in dollars. So what's a nice easy number of months that we can calculate the cost for? Someone said 1. How much will the cost be for 1 month? How much? $111? Agree with that? Because you got the initial fee plus the first month. Wait. Yeah, plus the first month of service. Is that right? What's an even easier one to look at?
0.
How about 0 months? So we're going to get cable TV. How much do we pay after 0 months? $75. Okay, someone said 2. How much will you pay for 2 months? Initial fee plus 2 months worth. What does it turn out to be? I'm hearing 147. Agree with that? How can we see if this is proportional or not? What do you want? Let's do something different than constant multiple. Let's do a different one. What do you want to do?
Scaling.
Scaling factor. So what's an easy one to scale here? 1 to 2. So scaling factor says that if you double the number of months, what should happen to your cost if it's proportional? It should double. It should be times 2. What do we think? So we're saying times 2, question mark? Nope. Not proportional. All you need is one case that breaks the rules, and you can say not proportional. Okay? Any other questions? So what is causing this to be, we'll get to this later, but what is causing this to be not proportional? That initial fee. That initial fee is kind of, if we had proportionality of like cost for months, right? But then when we start out with an initial amount, it makes everything kind of cattywampus. And we'll be definitely looking into that later. Other questions about this one, the cable TV? Another request. C. That's the sugar and flour? Okay, so we got a minute. Hold on. All right, so give me an amount of flour, an easy one, or something relative to what you're given. What is it? 2.25 cups. How much brown sugar? 0.75. Okay, so give me another amount of flour.
4.5.
If you had 4.5, that's double the amount of flour. Would you have double the amount of brown sugar?
Yes.
Sure. Okay, if I had 10 times the amount of flour,
You'd have 10 times the amount of
would I need 10 times the amount of brown sugar?
Yes.
Okay, what is the constant multiple for this? What is the constant multiple? If I wanted to write brown sugar in terms of flour, what would my constant multiple be? Times 3? So 2.25 times 3 would give me 0.75? You're on the right track. A third. So if I want to write brown sugar, I almost wrote BS, in terms of amount of flour, that would be B equals 1/3 times F. And our constant multiple would be 1/3. This is B in terms of F. Okay, you got your homework for next Wednesday. There's lots you can do in that. And I'll see you Friday. What? No, so the rest of you that didn't get checked, we'll check you Friday. Once you get close, you'll see signs. But PSA 21.